Okay. Hello, everybody. So welcome to CMPE212. This is Introduction to Computer Science number 2. You probably haven't seen me before, so I am Dr. Burton Ma. I'm a professor in the Computing Science department, but I am a licensed engineer. Actually, I'm Queen's alumni from EngPhys. There you go. My office is in Goodwin Hall, room 754. So you take the elevator up to the top, turn left, turn right. I'm in that hallway. If you need to find me, my office hours are Monday through Thursday, 1:30 to 2:30. Now, from what I remember of engineering, this may not fit into your schedules. So if this doesn't fit into your schedules very well, let me know, and I can add extra hours for this course in particular. I mostly teach computing science. I also teach this course. Well, this is the second time I've taught this course. One of the Thursday office hours might have to be canceled every month because I have departmental meetings which overlap with my office hours. If you need to contact me, you can contact me via email. Don't go through Teams or OnCue. I tend not to read messages from those sources, mostly because there's way too many students. I teach like over 300 students, so it's a little crazy. So use email, please. Put the course code in the subject line so I know what course you're asking about. Because I have 3 courses this term. If you don't tell me which course you're in, it becomes very hard to deal with your email appropriately. That's my email address. Feel free to use it if you need to contact me. And you can't make my in-person office hours. Look, all the information's on OnCue. Teaching assistants, course evaluation, everything's there. I'll go through it quickly. You have 2 teaching assistants. They'll be dealing with your labs mostly and marking your work. Of course, so the lectures are mostly, or are all there, I guess, on OnCue. So you go to the lecture section, you'll find them there. Lectures are recorded, so if you miss a lecture for some reason, you can get the recording later on. Textbook. There is no required textbook for the course, which is good because introductory Java textbooks cost an arm and a leg. It's not unusual to find textbooks for like $300, which is ridiculous. I wrote a free one. You have access to it. I'll show you that shortly. If you want extra textbooks, so extra reference sources, there's literally thousands of sources you could use. Right? There's, I don't know, dozens or hundreds of textbooks you could pick. You can find any number of websites on the internet. This one here in particular that I've listed here, oops, sorry. That first one, that is a very good textbook, mostly for its programming exercises. It also has a website, sort of. It's not really up to date anymore. But if you want extra programming practice problems, that is a superb reference. Not so good on some of the other aspects, but for programming exercises, it's very good. That second book there, I don't think most of you are going to end up in a career where you're primarily using Java. If you do, that book there is highly recommended reading. It's written by one of the architects of the Java language. Okay, there are labs. This being an engineering course, labs are mandatory, so there's no way for me to cancel them, even though I'd like to. So I inherited this course from somebody else. I don't know why the other person had labs. As far as I know, the only reason they had labs was to run tests. Why you would have 12 tests, I don't know. But they're here, and now we're stuck with them because of the way that engineering accreditation works. So I have to make up a bunch of labs for you guys. They start this Friday. Why does it start Friday and not Tuesday? Well, we only have 11 Fridays, and there is a Friday lab section, so there's only 11 labs. There's only 11 Fridays because of Good Friday. Right? So there's 13 Mondays for some reason, 11 Fridays. I don't understand. Anyway, does everybody here have a laptop? Does anybody not have a laptop? Let me put it that way. Okay, that's good. Please set up your laptop for Java programming. I'll show you how to do that shortly. Well, I'll tell you how to do that. Bring it to the labs, and then we can actually have programming labs. It used to be the case that we'd run the labs in a room in Jeffrey that had some really, really old computers in them. So really, you just show up and you'd use the lab computers. The university got rid of those labs. So now there are very few labs that actually have computers in them. So you have to bring your own. Grading, I'll get to that in a second. I'm going to show you OnCue in a second. OK, let's look at OnCue now then. Okay, so here are the lectures. They're all here. There's a link up at the top of the lectures page. That will take you to the online notebooks if you want to use them. But if you go to content and course readings and resources, like that, right? So if you're on a Mac, how many of you are on a Mac? Do engineering students use Macs? Oh, they do. OK, good. So if you're on a Mac, just click on that link. That'll take you to, I think it takes you to some videos, actually, to show you how to install the software you need. If you're on Windows, click on that link. If you're already using Linux, you can figure this out on your own. I don't need to tell you, right, because you're using Linux. Once you get the course software installed, so basically you need to install a Java development kit, and then you need to install something that you can program Java in. So in this course, we use Eclipse. If you've used a different IDE before, feel free to use the other IDE. I only support Eclipse, so if you have questions about your IDE and it's not Eclipse, I can't answer them. Or I probably can't answer them. But if you want to use Visual Studio Code, or if you want to use IntelliJ or something like that, no problem. Right? If you've never used Eclipse before, after you install the software, click on that link there. You'll get a video where I show you how to use Eclipse for the first time. If you want the source code for the course, you can click on that link there. That'll give you a zip file that you can import into Eclipse. It'll give you all the source code for the course. There's a lot of source code for the course. I don't know if anybody's downloaded and looked at it yet. There's quite a lot. OK, what else do you need to know? Labs, lectures. So lectures are there. So the labs, you're basically going to show up in your lab. You're going to get some sort of exercise to do. And then you're going to complete the exercise in the lab. There's no assignments. So you get all your work done during your lab time. So there's no extra time you have to spend, which you would probably you probably want to spend that time on your other courses. You don't have to spend any extra time outside the course doing assignments and stuff like that. Where is, what was I going to do? Lab. Oh, the grading. Yeah, grading. That's what you're going to want. Content. Course description. Here we go. At some point, read the syllabus. It's information you probably already know. It's just a common syllabus that we use in computing science, detailing some course policies and stuff like that. Textbook, no textbook, grading scheme. That's what you're going to be interested in. There you go, right there. So there's 8 assessed labs, right? So the first one will be Friday. Friday, Tuesday, and Thursday, right? Or something like that, where you guys have your labs. So the first one's Friday. You'll have a similar, hopefully not identical lab on Tuesday for the Tuesday people, and then a similar, but hopefully not identical lab on Thursday for the Thursday people. So this is the reason why it doesn't make sense to have a computing lab for a lab for a computing course. Anybody who does the Friday lab, as soon as you finish the Friday lab, the solution for the Friday lab becomes immediately available, right? You've done the Friday lab. Everybody who has a Tuesday or Thursday lab now has the solution to the lab. Makes no sense to have a computing lab. I don't know why we have one. Anyway, we have them. So I have to make slightly different labs for every section. There's 3 quizzes, right? So there's basically 4 main sections, 4 main parts to the course, right? Part 1 is you learn the basic language coming from C to Java. You'll have a quiz on that. Part 2 is you actually learn some of the object-oriented stuff that's in Java. You'll have a quiz on that. Part 3 is you'll do some more involved object-oriented stuff using Java. Quiz 3 is on that. The exam is on part 4 of the course. It's not comprehensive, right? So you don't have to write an exam where you have to remember everything in the course. It's also not 3 hours long, right? So your quizzes are done in the labs, right? So that takes care of 3 of your labs. The other remaining 8 labs, you'll have some, I hope, interesting exercises for you to do that are in fact relevant to engineering, which is why it's handy to have an engineering person actually teach this course rather than a pure computing science person. If it was pure computing science, you'd end up unfortunately with the people who took 212 last year. So last year was the first year I taught this course. It was basically the clone of CISC 124. It's changed this year, so it's actually more engineering oriented this year. The exam's scheduled by the exams office. It's probably going to be like an hour or 2 hours long. And again, it's only on, or it's primarily on part 4 of the course. Okay? Any questions so far? Super. What about these online notes? Hang on, I just have to load them up. What do I want to leave? Oh, that's sad. All right, so I'll explain why this doesn't work in just 1 second while I go back to... Okay, so the online notes, they're not static web pages. Right? If they were static web pages, I could put them anywhere and everything would be fine. What they are interactive notes, meaning you can read them, but you can also interact with them at the same time. So if you click that link, it'll take you to this page here. Notice it says CISC 124. That's not a mistake. The course notes are, sorry. I have to open that in a new window. That's what's going on. What was I saying? Oh, they're interactive. So you can open up the notebook, right? So the notebook is running on someone's server somewhere in the world. They're hosting it for free. Here it is. It's coming now. It says 124, but it's the same set of notes that are used for 124. But what am I doing here? I want to hide all of this stuff so that you can actually see something. Okay, so what you're going to see is when you hit this landing page, you'll see a whole bunch of links, right? These are all of the individual notebooks for this course, right? There's no way we can cover all these notebooks in great detail in 36 lectures, right? So obviously we're not going to cover every notebook in great detail. However, everything that's in it is in the course is in the notebooks, right? So if you open up a notebook, I'm just going to pick one at random. What do we want to do? That's not that interesting. Well, let's do some integer types. So if you open up one of these notebooks, it looks like a web page, right? So you've got some text that you can read, but you'll encounter these little gray cells every once in a while. Well, more than every once in a while. There's quite a lot of them, right? Again, this is written for the 124 student, so some very small amount of code is in Python. Just ignore it, right? You guys know C, so I haven't had time to rewrite these notebooks in C. There's a little arrow here. You can click on that arrow, and that code will actually run in this web page and print something out. So you get the output right here, right? So that's 10 to the 100, right? 1 Google, right? You can go into this code cell and you can edit it. So I can compute 10 to the 10 and run it instead. And it runs right in the code cell, right? So you can go in and edit these cells. You can even edit the text if you wanted to, but it lives on someone else's server, so it won't stay edited. And you can run all these cells. Now this is cool because you can go into a Java cell like this one, right? And instead of writing a complete Java program, which is what you'd have to do if I didn't give you this sort of thing, right? You have to open up your IDE, you'd make a Java program, you'd have a main method, blah, 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 just to run these 2 lines of code, right? Whereas when you're learning something, it's much easier to say, hey, I can just run it right here. Lo and behold, it runs, right? You can go in, change something. What do I want to change? Int value, okay. So integer max value, that's the largest int value that Java can represent, right? It's this number right here, right? So if that's the largest value that Java can represent, what happens if I add 1 to it? What do you get, right? Yes? It does roll over. Where does it roll over to? It does roll over to the negative value, but you can check that right in the note. Oh, hang on, sorry. Maximum int value. But why did that happen? That should not have happened. Just a second here. Oh, I know why that happened. You need the parentheses here for complicated reasons. Run that, and it does in fact roll over, right? And you might think, hey, that's weird. Why does the int value roll over? Well, it rolls over in C too, whether they told you that or not. Did they tell you that? Whoever taught you C didn't tell you that. The int values roll over in C too, right? You take an int value, you add another int value to it, and it exceeds the largest value, it rolls over. What happens if you take the smallest int value and subtract 1 from it? You should not be surprised. It rolls over, but the other way. Whoop, right? So it rolls over to the largest positive int value. And this is the way it works in C. This is the way it works in Java. It's not the way it works in Python, right? And you might think, this is crazy, and yeah, you're sort of right. It's just the way it works. So you have to realize this is a limitation of the language, right? And so you can go into these notebooks, you can run all these cells, right? You can read the content that's there. The notebooks goes into much more detail than I can go into during the lectures. What else do the notebooks give you? In every notebook there are, somewhere, so they're sort of scattered randomly throughout the notebooks, exercises, right? So there's a bunch of exercises in the notebooks somewhere, wherever it's most appropriate for the exercise to appear. And you can actually do the exercises either in your notebook or in the IDE if you want to work in the IDE, right? And you say, that's great. Where are the answers? The answer is, well, they're right here. Every section has another notebook that contains all of the exercise solutions for you. So as soon as this loads, there we go, right? So for every notebook, so the notebook dynamic versus static typing, here are the exercise solutions, right? Which you can also run directly in the notebook itself instead of having to do it inside an IDE. When you're using this, when you're using the online notes, you have to be a little bit careful. So if you go away and get lunch or something like that, you're going to see the same funny message that I had when I first opened the notebook, right? It says the kernel's crashed, blah, 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 right? The reason that happens is because these notebooks are actually running on someone's server for free somewhere else in the world. If you're not using the notebook, they shut down the notebook so that they can release their server for somebody else to use, right? So if you pause, I think it's like 5 or 10 minutes. In other words, if you don't do anything on a notebook page, it's possible that you have to reload the notebook again, right? But otherwise, the notebook should be fairly quick to load because there's a lot of students who might be using it. If there's only like one student using it, then they'll be slower to load because they don't keep a version of the notebook stored anywhere. They have to re-download the environment and everything. All right, any questions so far? Super. All right, let's see. So what is this course about? So there is a calendar description, but really what this course is about is it's your first course, probably your first course in object-oriented programming, right? And the language that we use in this course is Java, which is, frankly, is a slightly unusual choice for engineering, but that's the way it is. Okay, so first of all, what is object-oriented programming? Since you probably, if you haven't taken Java or object-oriented Python in high school, you don't know what I'm talking about, right? Because you've just learned C. C is definitely not object-oriented. So in C, you've got data, right? You got variables, maybe global variables, maybe they're variables in a function somewhere, right? And then you have functions that operate on the data, right? So you can write a function that takes in some value, does something with the value, returns another value, right? That's what you call structured programming, right? So things like structured programming includes things like if statements, loops, calling functions. Right? Object-oriented programming is different in the way that it organizes information. Right? So information in an object-oriented program lives in these things called objects. Right? That's why it's called object-oriented programming. Right? Furthermore, the objects have what you would think of as functions that can operate on the data. Right? So in other words, the functions are bound to these objects. Right? So in object-oriented programming, you gather information and functions that can operate on the information into a single place. Well, maybe not necessarily a single place, but they are grouped together. Right? Whereas that's not necessarily true in a language like C, right? Where you can have data in one C file, functions in some other C file that operate on the data in this C file, and functions somewhere else that also operate on the data in another C file. Right? I don't know how big a C program you've ever built, but you can easily have a C program that has hundreds of C files, and they are operating on data that live all over the place. Right? In object-oriented programming, we try to group the information and the methods that operate on the information into one place. The objects can talk to one another. Right? So this object knows something about some information. This object knows something about some information. They can communicate to access and modify the other object's information. Right? There are many other types of programming, programming paradigms, right? Ways of doing programming. These are the most common two that you learn. These are the most common two for introductory programming. There are other very, very, very different programming paradigms out there. I don't think as engineering students you ever take the computing science course where you learn about other programming paradigms. But there are many other ways of doing programming other than object-oriented or procedural. Okay, so what's Java? So Java is the language that we use in this course, frankly, because the computing science uses Java. The computing science department uses Java, and it's the computing science department that offers this course. Is it the best object-oriented programming language for engineering? The answer is almost certainly no, but this is the situation we're in. So Java is what's called a general purpose language, right? So it's like C. You can write a C program that's suitable for many different types of problems. right? Similarly for Java, you can write a Java program that's suitable for many types of problems, right? It's not ideal for everything, but it's suitable for many types of problems. So that's what I mean by general purpose. Cross-platform means it runs on many different types of computers, right? It can run on your cell phone, it can run on your desktop computer, it can run on a supercomputer, it can run on a server somewhere in the middle of nowhere, right? And it's object-oriented. Java is a newer language than C, right? So since you guys learned C, you may have realized at this point in time that C makes the programmer do an awful lot, right? If you want to print something in C, you probably have to go through printf, right, and do some sort of formatted printing. If you want to, so that's just printing. If you wanted to, say, for example, create a list of stuff, you would use an array, right? If you wanted to add more things than the array can hold, you have to make a new array, copy all the stuff from the old array into the new array, and keep on going, right? So C is a lower level language than Java. Java does more for the programmer than C does, right? And the reason it does that is because of these things here. So when they designed the language, they tried to give it certain features, right? At the time when they created the language, C and C++, whoa, sorry, those, where are we going? These were the dominant languages at the time, right? They are still dominant languages today, right? And Java would be one of the, there's 4 dominant languages right now. Python, C, Java, and C++, right? And that's followed closely by a whole bunch of other languages. Those are the 4 big languages right now that are used. I guess those are the 4 general purpose languages that are commonly used right now. Okay, so where is Java used? So it is used in some scientific applications. So it's not completely it's not completely inappropriate for teaching engineering. In particular, NASA uses it a lot for many of their applications. Where it's really used, though, is what's called enterprise software. So this is software that the ordinary person never sees. But in these giant organizations, right, like a bank, which has tens or hundreds of thousands of employees, right, internally, there's a whole bunch of software that that organization uses to do things like keep track of its employees, do payroll, all sorts of applications for the employees to use, right? That's typically where Java is commonly used. That's typically where Java is used. Right? On the internet, Java lives on a lot of servers. So all the infrastructure that drives the internet, Java has uses there. If you've heard of big data, Java has applications in big data. These little devices that you wouldn't think is a computer, right? Doesn't have a screen, doesn't have a keyboard, right? Doesn't have a, may not even have a network connection, right? A lot of these devices actually have a computer inside of them. These devices are called embedded devices. So there's some sort of embedded computing. A lot of these embedded devices run Java. Again, some scientific applications use Java. And some indie video games are programmed in Java, although not very many. If you want to program video games, you should probably learn C or C++. You won't easily find a job in Java. Yes?
There's some advantages Java has, and that's why it's used in enterprise software.
Yeah, it does. So there's a entire version of Java called Java EE. The EE stands for Enterprise Edition. So there's a whole bunch of libraries that are written especially for enterprise organizations that help making writing software for those organizations easier. Right? Things like connecting to databases, things like doing networking, things like talking to other computing systems that aren't in Java. So Java has all of these libraries that are already created to build those applications. So that's a good question. I mean, that's why, because of the existence of these libraries, that's why Java is appropriate there. These types of systems also have, they don't necessarily have to be high performance in terms of computing, right? You're not crunching billions of numbers per second. Java's not so good at that, right? C is good at that. Java's not so good at that. That's why Java's not so good for video games, right? Video games, if you take the computer graphics course in 4th year, you'll learn a little bit about how computer graphics works, and you'll realize that computer graphics is just crunching big streams of numbers all the time. Java's not so great at that. All right, any other questions? That link there if you have time, and if you're interested, the company that now manages Java, they wrote a little article that where they ranked or they picked what they thought were the 25 greatest Java apps of all time. Many of these apps are NASA applications. It's pretty impressive what the language has been used for in NASA. Okay, so in this course, you need to use Java. What this means is you have to install 2 pieces of software. You need a Java development kit, right? So the instructions are on OnCue. There's even videos, walks you through the whole process. And then you need to install something where you can program in, right? So I recommend you use Eclipse. That's the IDE I'm most familiar with. That's the one I can help you with. And that's the one that's supported in the course. You can use things like Visual Studio Code if you like to use Visual Studio Code. You can use IntelliJ or any other reasonably sophisticated IDE. Right? There are a bunch of teaching IDEs which would not be appropriate for this course. So you just need to install 2 pieces of software. Normally, if you follow the instructions, it should go seamlessly. It should take maybe 20 minutes at the most, right? Unless you have a really slow network connection. Oh, we're not done yet. All right. So I'm just going to jump into lecture 2 because we've got like 20 minutes left. And we'll actually do some, we'll actually learn something about the Java language now. Okay, so my job in the first 4 or 5 lectures is to transition you from C into Java. Now the good news is, yes?
I'm just wondering, like, what's kind of the difference between the lectures you're giving in class and then the interactive
notebooks have way more detail in them than I'm going to go in the lectures. They'll use, and they're going to use different examples in the notebooks versus the lectures.
And then we should just go through that on our own time.
Sure. Yep. I mean, in principle, you could just go through the notebooks. Everything that's there, they will cover everything that's in the lectures. Yeah. But there's a lot of notebooks to work through. Like, there's a lot of material in them. All right, so let's see. The good news for you guys is that you know C. And Java was created to be familiar for C programmers. So things like writing loops, if statements, creating variables, those sorts of things, you already know how to do, right? So there's not too much that I have to tell you to transition from C to Java, right? Okay, so you know that if you're going to write a C program, you create a .c file somewhere. You might have more than one, right? But you create a .c file somewhere, right? That's your C source code file. Inside that source code file, there has to be a main function, right? And your main function, hopefully they taught you, looks like that or that, right? One of those 2. C is a funny language. It's very old, so there's many variants of C. So the version they showed you may not have looked exactly like that, but it was called main for certain, right? This is hello world in C, right? So you take this program in C, you'd run it through a compiler. If everything's fine, you would run the compiled program, and you'd get hello world, right? Well, okay, Java also starts running from a main method. So Java calls it a method, not a function. So Java program also starts running from a main method. It looks different than the C method, the C function, right? So C, it's always int main something, right? Java, it's always public, static, void, main, and then something, right? So it always looks like that. Notice that it's quite a bit more verbose than C, right? Also notice that in Java, that main method has to be inside this thing that's called a class, right? So I'll tell you about classes and objects and all these things later on, probably in the next lecture, right? But if you wanted to write hello world as a Java program, this is what you'd have to write, right? Public class hello world, brace, then you'd stick the main method inside, right? And then you'd have this line here, and that line there prints the string hello world. So notice that the string, hello world, right? That looks a lot like a C-style string, right? A C-style string literal, right? Any string that you can actually write down, right? It's inside double quotes, right? The print method in Java is this thing system period out period print ln, right? So that's the equivalent to puts in C. Okay, so you're allowed 2 forms of the main method in Java. So it can look like public static void main string ... args. Or it can look like public static void main string square brackets args, right? Either one's fine. there's no real difference between the two. So you can use either one of them, but it has to be one of those two. If you try to create a method that looks, where that, or that is different, it's not, Java doesn't consider it to be a main method that you can run the program from. You can put it in your program, you can't run the program. It has to look like one of the two things in red that I showed you. Okay, what is this class thingy here? Right? So that main method has to live inside a class. That's the rule in Java. Right? So when you make your class, you just write public space class space, and that's the name of the class. Right? You have considerable freedom over what you name your class. Right? You can call it pretty much whatever you want. However, when you name the class, experienced Java programmers will expect you to name it in a certain way. Right? They're going to expect the first letter of the class to begin with a capital letter. Right? So that's big H hello world, not little h hello world. Right? If you have a multi-word name, they're going to expect every word to also start with an uppercase letter. Right? So this is what computer programmers would call upper camel case. Right? So that's the naming convention that you should use for a Java class. Right? There is a reason for it, right? Which I'll explain shortly. Right? So there's a reason why Java programmers want you to write it this way. You are allowed to use underscores in the name, but you should generally avoid them unless you're doing something unusual. Okay, just like in C, a Java statement ends with a semicolon, right? So this is not new to you, right? That print line statement there ends in a semicolon, just like a C statement typically ends in a semicolon, right? All right, now in C, right, you can write double quotes hello world, right? And that's a string literal, right? That's a string that you can write down, right? C doesn't have its own separate type for strings, right? You should have been told that a string in C is just an array of car, right? So hopefully you know that. If you don't know that, you know that now, right? So the array S, it's a C array, right? It's made up of car elements. Right? So that H is a car, that E is a car, the L is a car. Right? Hopefully they also told you after that exclamation mark there's another car. Right? There's the digit 0 or \0 after the car, after that exclamation mark. Right? There's a null terminator at the end of every C-style string. If you don't know that, don't worry about it. I'm not going to ask you about it. Right? Okay, Java has its own string type. Right? So all of this, I don't know how much string manipulation you did in C. Did you do any? Yeah. So all that crazy string manipulation that you had to do in C, Java makes it a lot easier to do. So strings are, I guess, they're first class. They're an actual separate data type in Java, right? So if I want a string in Java, I can write big S string, right? Give it a name, and then I can store a string in the variable S, right? Now I can reassign that string. Right? So I can, instead of storing hello world in S, I can store, I don't know how to pronounce that. That's also hello world in another language. Does anybody know what it is? Anybody? I don't know what it is. I forgot what it was. I just Googled hello world and stuck them in. So you can also store that string in the variable S, or you can store that third string in the variable S. Right? You can't do that with C arrays. Right? If you try to assign something to S here, right, it won't work because you can't assign to a C array. Right? If it was a pointer, you could reassign it, but here it's an array, so you can't do it. Okay, so performing simple tasks with strings in C is tedious and error-prone, in particular because C just uses a raw array to hold the characters. Right? So in C, if I make my string S, right, and I make sure that I can hold 13 letters, right, and I can store the string hello in that array, that works just fine. Right? If I take T, and it holds 1, 2, 3, 4, 5, 6, 7, 8, plus the null terminator, so 9. So it has length 9. And I try to join those together using string cat. Right? So join S and T, storing the result in S. Right? That blows up on you in C. Right? And it blows up on you silently. Right? It might look like it works, or it could crash your program, or something else could happen. Right? So in C, this results in what's called undefined behavior, right? Because the string S, the array S, doesn't have enough space to hold all the characters, of the joined string s and t, right? In Java, all you do is write s plus t and away you go, and you don't care if there's space or not, right? The language, the string class, takes care of allocating all the memory and makes sure there's enough memory for the concatenated string, right? So s plus t takes s and t, joins them together, gives you back a new object, which you can store in u. Right? So that's nice, right? Concatenation, just use plus. Printing text in C, you use printf, right? Or something else, right? Usually it's printf, though. And then when you want to print something, you have to know what is the type of the thing you're printing, and then you have to use a different conversion. And if you want it to have a certain width, you got all sorts of crazy things, right? So if I want to print CMPE212 using printf, right, I could use %s to convert the string to a string, right? I can put a space in. I can use %d to convert the number or to interpret 212 as a number, right? And then I can put in \n for the new line, right? And that would print out CMPE space 212 new line, right? Not terrible when you get used to it, but you could do the same thing in Java in the following way, right? So I can have my string CMPE. I can have an int 212, right? I can print the subject. I can print a space. So notice there's a difference between print and println, right? So print does not go to the new line. Print line goes to the new line after printing the thing, right? So that prints out CMPE, then a space, then the number goes to the new line, right? Or I can just use print line and join everything together with the plus operator, right? So I can take the string, right? Add a space to the end of the string, add a number to the end of the space, and you get the string CMPE space 212, and it prints that. Right? So you can use string concatenation to print a string in Java, right? So all sorts of string manipulations are much easier in Java than they are in C, right? Now you know that in C all variables have a type, right? The type is declared along with the variable name, right? So here s is an array of car, here t is an int, right? Here arr is an array of int, right? You know in C that once you make a variable within the same scope, you can't change its type. Right? So inside this scope here, right, the name s is always an array of car, right? The name t is always an int, right? And variables can only hold values of the declared type, right? So I can store an int in t, I can store a string or an array of car in s, right? And in here I can store ints in this array arr. Java is exactly the same, right? So it's all the same stuff. Arrays look different in Java than they do in C, right? So in C, you would normally create your array like this. Java programmers normally write it like this, right? So int square bracket, so the array, the square brackets come after the variable name, after the variable type, not after the variable name, right? When you make an array in Java, right, you have to use this funny syntax here, right? You have to write new and then int 3. So that basically says make an array, right, that can hold 3 ints. So that's what you write in Java. We'll talk more about arrays in the next lecture or so, right? But otherwise, once you have the array, you use it exactly the same as you'd use the array in C. Okay, now when you're making variables in Java, Java programmers expect the variables to be named a certain way, right? They expect it to begin with a lowercase letter, right? So you should use lower camel case for your multi-word variable names, right? So my variable s is lowercase s, not uppercase s, right? My variable t is lowercase t, not uppercase t, right? And my variable an array is made up of 2 words. So the first word, lowercase, second word starts with an uppercase letter, right? Now the reason why Java programmers insist on this convention, right, is because if you made a variable here called big S, right, and then somewhere in the program the name big S appears, right, when you use the variable, right? To a Java programmer, it looks like you're using the class called big S, right? Because all classes, like string, begin with an uppercase letter, right? So whenever a Java programmer sees an uppercase letter or an uppercase name somewhere in their program, they think, oh, that's a class, right? They don't think, oh, it's a variable, right? They think, oh, it's a class. So your variable names should always begin with a lowercase letter. Class names should always begin with an uppercase letter. Comments in C are the same as in Java, right? So the double slash is the line-ending comment in both languages, right? The code here is not that important. This is all Java. It's doing the compounded interest formula. It's not that important. Right, we're going to talk more about this calculation down here later on. Right? You can also use the slash star star slash convention for comments. Right? Again, identical to Java to C. Right? Okay. I don't know which version of C they taught you. So before C99, so that's the 1999 standard of the C language, there was no type for true and false, right? So you were probably taught that true is, false is 0, right? True is any other non-zero number. That's probably what you were taught. Is that true? Yeah? Okay. There is actually a true-false type now. But anyway, so in C, if you wanted a variable to store a logical value, right, true or false, you'd use an int, right? So TF is true or false, right? I'm going to start as false, right? So if it's false, print true. If it's true, print true, otherwise print false. If you ran that program, it would print false, right? If you changed that 0 to anything else, it would print true, right? Java has a special type for true-false values or logical values, right? It's called Boolean. You cannot use a number as a Boolean in Java, right? So all that stuff they taught you about zeros and not zero, you have to forget all about that in Java. It doesn't work, right? So if you want a true-false value in Java, it's type Boolean, right? Your literals are true and false. Lowercase true, lowercase false, right? So I can start by setting TF to false, right? If TF, so is TF true? The answer is no. We go to the else statement, prints false. You can also print TF, right? Here I'm printing the string true, I'm printing the string false. I could just print TF here, and I could just print TF here, and everything would work just fine. Print line is smart enough to convert that variable, which is false, to the string false when you print it, right? It's smart enough to convert the value true to the string true when you print it, right? So all of the conversions for printing numbers, Boolean values, and other stuff, print line does for you automatically. Okay, so in C, you were probably told about int and double, maybe int and float, right? Were you taught about anything else? Were you told about the unsigns and all these other things that I'm showing you here? Oh, you were taught. No, yes, no. It doesn't actually matter. It's not a C course, right? You know what an int is, right? You know what a double is. You know what a float is. You know what a char is, right? That's all that you really need to know. C has all these other types as well, right? Signed char, unsigned char, short int, blah, 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 blah. So you got all these other types. They're just variations. These are all just variations of int, right? Java has fewer types, right? So these are all also integer types, right? There's something called byte. There's something called char. There's something called short. There's something called int. There's something called long, right? Primarily in this course, we're using int. Right? We're going to use char because those are the elements of a string, right? And you're going to use long because sometimes you're going to compute some value that doesn't fit in an int, right? Will I tell you anywhere? No, I don't tell you anywhere. Okay, in C, C is a funny language. So because it's so old, there's C code that's still used today that ran on a computer that was probably, or was originally written for a computer that was probably developed in the 70s. Right? So 50 years later, that code is still kicking around. C doesn't actually say how big is an int, right? So it doesn't say what the minimum value is. It doesn't say what the maximum value has to be, right? It's up to the compiler to determine what is the minimum int value, what is the maximum int value. And it depends on what computer you're running it on and a bunch of other things, right? So C says an int, it's an integer value. It's got some minimum value. It's got some maximum value. It has some minimum size. Java actually says what the sizes are, right? So Java says int is 32 bits, right? Long is 64 bits. Short is 16. Char is 8. Char is 8? Char is 8 or 16, I don't remember. Byte is 8. Sorry, byte is 8. Yeah, byte's 8. 8 bits, right? So in Java, all the sizes are fixed. Oh, sorry. You also know about the floating point literals, right? Double and float. C also has long double. They almost certainly didn't tell you about that. Right? Did they show you scientific notation? Oh, you're engineers, you should know this, right? Okay, so scientific notation, you can write down a float literal or a floating point literal using some decimal number here, right? So like 1.5 or 1 or 3.141516, blah, 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 right? And then you can use e. So e is times 10 to the power 1, right? So that's 1.5 times 10 to the power 1. That's 1 times 10 to the power 100. That's also 1 times 10 to the power 100, right? So there's this thing called scientific notation that can be used to write and print floating point values, right? It works the same way in Java, right? In fact, float and double work exactly the same way as float and double work in C, right? And these are all mandated by this standard called IEEE 754, right? Java also has the scientific notation. Okay, so unlike C, Java says all of these types have a particular size in memory, right? Bytes always 8 bits, chars always 8 bits, shorts always 16 bits, ints always 32 bits, right? A bit is just a binary digit, right? A 0 or a 1, right? Each type, so hang on, okay. So each one of these types, you'll notice that they occupy a fixed amount of memory, right? Int is always 32 bits, right? So what's the implication of that? Well, there's only a finite number of ints, right? You know that in math, there's an infinite number of integers, right? But int can only hold a finite number of them, right? 2 to the 32 of them, in fact, right? What does that mean? It means there must be some minimum value, right? So minus 2 to the 31. There must be some maximum value, right? 2 to the 31 minus 1, right? If you go beyond either end, then it looks like what I just showed you earlier, ints wrap around, right? And we'll look more at that in detail a little bit later. So this is the part that should probably make you happy. There are no pointers in Java, right? So all of that stuff that you learned about dynamically allocating memory, getting addresses of stuff, pointing to stuff in C, Java says, this is very error prone, we're going to get rid of all that, right? They didn't actually get rid of it, they actually hid it from the programmer, right? So there is no mechanism in Java for directly accessing memory, right? You don't have to worry about allocating memory, you don't have to worry about freeing memory. The language takes care of all that for you, right? So Java programmers generally not concerned with allocating memory for objects, right? You're generally not concerned about pointers pointing to somewhere they shouldn't, right? You can't have a reference in Java that refers to something that it shouldn't, right? You don't have to worry about deallocation, right? The language takes care of that for you. This was one of the big design changes that the Java language made relative to C and C++, right? It took all of this dynamic memory allocation and the issues that go along with it and hid them from the programmer, right? And so that's one of the big changes between the two languages. And I think I've talked enough. Yes, we'll continue this in the next lecture. Any questions before we go? All right, thank you, everybody.